Hello grade 12, welcome to my channel. Let us discuss some more NBT related practice questions and hoping that this may put a seal to most of the work we've been doing in this regard. Hoping that also you guys are going to be learning the skills necessary to navigate such exams rather than to attempt to cram these in the hopes that you might see these questions in the exams. The reality is you will definitely see similar questions, but maybe to some extent the same questions, but the bulk of the exam will always be stuff that probably you're seeing for the first time in the majority. So it should not be a problem for someone who's well prepared and who understands how to get the work done. Now, let's have a look at these questions. I've found this document on the internet, so I hope it sparks no problems, me doing these questions in this video. There's a bunch of 40 questions in here that you guys are going to experience, but to avoid the video being long, I may cut it in half, do 20 questions, and then do another video and do the last 20. It will depend on how well the movement is. Okay, right, skimming and scanning through these questions, some are technical in nature, and there are certainly complex questions where an indirect approach is rather the way forward than the usual. So stay put and learn as much as is possible. Please read through the text and make sure you understand what's cooking. So this is probably all thanks to, not probably, but certainly all thanks to Alan Christensen, who seemingly have developed these questions or compiled them. Whichever it is truly a pleasure to come across such a document. Now let's just have a look at these questions quickly. Let's make this one a bit smaller. I feel like it's too much. All right, so let's get to question 1. So here we are told that an ordered set of 7 data points. Ordered set of 7 data points. So what do we mean ordered? How do we order data points? We order them from the smallest to the biggest. Right? So that's basically how we order data in statistics. Okay, with no outliers is given as follows. We've got A, 15, B, 15, C, 40, D, where A, B, C, and D are element of integers. Okay, so cool. Now we've got to evaluate the maximum sum of A plus B plus D. Now conceptually, what does a maximum mean? It means the biggest possible value. Right? So the biggest possible value. So obviously from just the conceptual understanding, we're just looking for the biggest sum here. And the one is option B. So at times you don't want to put too much thought in some questions because it's a matter of just understanding conceptually what this question is asking for. So this is just simply B. Now, at times you may want to explore this and say, okay, what could be the possible value for A, for example? So what should A be? If we're doing a maximum sum, it means A must be as big as possible. Now, seeing 15 is repeating here, most likely the biggest A can be is 15, right? And if we look at B, B being interspersed between 15 and 15 must itself also be 15. That would be the biggest value it can be. Now, looking at C, it certainly should be 40 if we're looking at the biggest possible value for C. But the problem would come with D. D can be any other value in range or within the domain, so to speak. Now, we cannot really ascertain what value that should be. As a result, we can see that, well, even if we don't know that for sure, but we certainly to understand what the question requires. All right, so let's look at question 2. So question 2 says, in a convergent geometric series, what do we understand by this? Convergent, what understanding comes to mind is that r should be less than 1, but greater than -1. That's the main characteristic of a convergent geometric series. Now T1, which is A, and the sum of all terms is 3m. Okay. Now which one of the following is true? Now we can see that this is all regarding the possible values of A. Okay. So what helps is, guys, always look at the options so that you can gain an idea of what is expected of you in a particular question. So what should the values of A be, or what do the values of A range between in regards to the sum and whatever else is in here? Okay, so we know, folks, that again, if we say sum of all terms here, we are referring to sum to infinity because this is a convergent geometric series. So we know that sum to infinity is going to be A all over 1 minus r. Okay, r in this case should range between 1 and -1. Now we're told that this is 3m. This is equal to A over 1 minus r. Now this is all over 1. Cross multiply. We can see that A becomes 3m into 1 minus r. Right. So now in this case, we are somewhat in trouble. So how do we move around to try and uncover what is going on here? Now there's a few things to consider. We know that 1 minus r, when r is positive, okay, let's say r is less than 1 but greater than 0. We know that this becomes a proper fraction. 1 minus r is always a proper fraction. All right, so this is to suggest that essentially this reduces the value of 3m, meaning A is going to be less than 3m. Right? Now we can think about it and say, look, okay, this is possible because if r is positive, but we know that it is a proper fraction, this will always yield a proper fraction. So this reduces this value. So we can say safely A is less than that. But this only applies if m is also positive. Otherwise, if m is not positive, then this is a different story. Okay. So with variables, we always have to think about the signs. Okay. So if m is positive, this would be the case. But at the same time, we can make this conclusion that A, what would A be? It would be greater than 3m when m is less than 0. Because m could still be any possible value, even including signs. So this is key. Now, if we look at our inequalities, do we see something that is suggesting as much? No, we don't. We really don't. But we do have A less than 3m. So this one is cool. This one is cool. Okay. But we don't have one that somewhat caters for this. Right? Yeah. That would be the situation. And obviously, if m is negative, A being greater than this, when we multiply this by a negative in this scenario, what would happen? If we multiply this by negative, A would also acquire a negative. A would be less than minus 3m instead of greater than. So this is already somewhat not telling the truth. Okay, So this is what we have. Now we can see that, okay, how about we multiply that sum by 2, for example? Would we get something equal to, because this is a proper fraction, it certainly won't be equal to, right? It can't be equal to 6m. But if it is less than 3m, this is possible to be less than 6m, so to speak. Right, and when m is greater than 0, obviously a would also be greater than 0. That's possible. At least this is what we have. Okay. Right. Right. Okay. Now, this is one aspect. Now, what about the second scenario in this? Now, if we look at a situation where we've got r is less than 0 but greater than -1. This is to say r is negative while maintaining its proper fraction nature. So what would this help us to conclude? We now know that, okay, what would happen here is that 1 minus r is going to always be an improper fraction. Right? In which case, we can make this conclusion. If this is an improper fraction, now this means it's going to be bigger than 1. So this amplifies that value for a. So essentially a becomes greater than 3m, provided m is greater than 0 also. All right? So this is what would be the case. Okay. But what happens when m is less than 0? If m is less than 0, a would still remain. Okay, let's say m is less than 0. So a becomes even more negative, isn't it? So if a becomes more negative, let me just think for a second again. If this is negative, then this is going to be amplifying it, meaning it becomes more negative. So it means a becomes less than 3m when m is less than 0. All right, so again, this goes to agree with the first scenario to some extent. Okay, so now, do we see anything different in this regard? We don't have an option where our a is greater than 3m, so to speak. We don't see it here. But this condition we've already dealt with, and we can to some extent accept it. Okay, all right, okay. Now, folks, yeah. Now, in this case, we don't have a clear-cut answer because we've got somewhat two options that are possible. Now, this requires a bit more deeper view. Sometimes with these kinds of questions, there's no clear-cut, approach. And please try not to get to the exam for the first time you're starting to realize these issues. These are things that should have been highlighted through working these problems in your practice sessions, either for your standard examinations or whatever process you might have had to go through in this regard. So this is just me to highlight some of these things so that you think about them when you get technical questions. Now we can already see that this doesn't help us much because we still remain with two possible answers, which certainly there's only one. Now let's get to business. We can say here, folks, however, knowing that r is less than 1, greater than -1. In maths, we are allowed to kind of multiply by anything we want. So how about we multiply by -1? Of what use is this? We are going to achieve minus r, isn't it? So we're trying to create this scenario over there. But now these ones are going to flip because this becomes greater, in which case minus r becomes less than a +1, and this one flips to the other side. it becomes like that. Okay. Now from here, we want to create a 1 minus r. We can do whatever we like in maths, guys. How about we add 1? So when we add 1, we're going to have 1 minus 1 less than 1 minus r less than 1 plus 1. Understand? So in this case, we've got 1 minus r. Maybe let's not say it's a conclusion as yet, but it's rather an implication. So this becomes 0. This becomes 2. Okay, now we've got this situation, but now we want to achieve this whole scenario. So in maths, we can again multiply by anything we want. So if we multiply here, we're going to have 3m into 1 minus r. But now the only problem with this is that not knowing the sign of m with inequalities, it's rather not advised to do this carelessly. But again, we're dealing with NBT type questions, so some serious situations, we may have to consider them as we would then have an answer guiding us as well. But now we see that we've created an expression that looks like A. But now let's just simply say where m is positive, this would be essentially 2 times 3m, this becomes 6m. If we multiply it by a positive number, nothing changes. So this is what we end up with, provided we're saying m must be greater than 0. This would be the scenario. Okay, we have to consider all possibilities. Therefore, what is 3m times 1 minus r? It is a. So a must be less than 6m, greater than 0. Do we see that answer? Option C is saying so. Okay, so most likely this should be the answer. But now what happens when m is less than 0? Now dragging from this, we would know that, okay, 3m into 1 minus r must be less than, technically if we say m is negative, what would this be? It would change this sign, so 0 would come this side, and then this would go that way. Right, because the signs would change around. Again, this would conclude that a must be less than 0, greater than 6m. So essentially, we don't have that option. As a result, the only answer is that. So you can see, guys, this one is not so easy. So the correct answer here is C. All right. I hope you've enjoyed this expedition. So the correct answer becomes C. As you can see, it's not so easy. Of course, with experience, it's very easy to navigate these questions because these type of inequalities have been taught in grade 10 already. It's just that this time around, nobody tells you to use that knowledge. You have to draw from it and move forward. Okay, let's look at question 3. Now question 3 says the square root of 15 minus 4 root 11 is equal to, so this is essentially saying evaluate. Now folks, the one thing for sure is that there's a sign between the terms under the square root. Now there are no laws or rules that we can follow for this. Now it means our logical thinking should come into the picture. Now what I do to get around these kinds of questions, I look at the options that I have to try and gauge of what could be the way forward. I mean, from experience, folks, you will already know certain things in terms of how possible they are and how unlikely they are. Now let's have a look. We've got a binomial under the square root. Is it possible to end up with a binomial like A, B, and C? Yes, pretty much it is, provided that binomial can be expressed by a perfect square quadratic trinomial. In which case, when we factorize that, we get a perfect square type of a thing. Okay, so these are possible, basically. right? They are very much possible. Is it possible to end up with a monomial from here? Looking at this, root 11 and 15, yikes, it doesn't look like it, but we can say fine, you never know in maths, right? You never know. Now the second thing we look at is, look, this is 15, this is root 11. So it would make sense to have root 11 in here. So I would say, well, most likely this can happen as well as this. But to end up with the square root of 15 for this, highly unlikely. So as you can see, you're already trying to figure out what to expect. But of course, you may not know for sure. Let's then get to the problem before we waste too much time. So here we've got a square root of 15 minus 4 root 11. Okay, so we're going to try and say, fine, is this possibly something we can write in such a way that it resembles an algebraic quadratic equation, which is a perfect square? Okay, what do we know? If we use 11 as our, yardstick, we can say 15 is 11 plus 4 minus 4 square root 11. Okay, right, so this is cool. Now how about we write this as a quadratic? So this is going to be 11 minus 4 root 11 plus 4. Okay, this looks right. Could we factorize this thing? But before we even think about factorizing, what does this mean? We know that 11 came from root 11 all squared. So we can write 11 as root 11 all squared minus 4 root 11 plus 4. Now we can see we certainly do have a quadratic expression under the square root. Let's factorize it as we know how. So this is dealing with arithmetic in an algebraic sense. So obviously we're going to take what is under the square. The factors of 4 is going to be 2. And then we take what is under the square again. Again, it's going to be minus 2. Now, indeed, we see that this is a perfect square because we can simplify this further by saying all this says is that we've got root 11 minus 2 all squared. Now, the nice thing is that the square root and the square take each other out, and our answer is root 11 minus 2. Okay, so that's basically the answer. So this one simply gives us what we want. So option C is our friend. Now, some people may still get confused when they get to this stage. Some would prefer to write and say, perhaps let the root 11 be equal to x, in which case we're going to end up with the square root of x squared minus 4x plus 4. And this essentially providing us a much clearer view of things. Either way, folks, how you see it is how you go through it, isn't it? And all we end up with is x minus 2. But then what is x? Root 11 minus 2. So at times one may, try to create an algebraic equation out of an arithmetic expression, in which case one must always have an open mind. So gain experience, folks, and learn how to deal with these problems efficiently. Okay, so let's have a look at question 4. So question 4 says we need to evaluate sigma from 25 to 65 of cos squared n, and we want the sum here. So this is sequences and series. Now, folks, once you see sigma, you know what is expected, right? Yes, n is equal to 25. So this must be 65 with cos squared n. What does this equal to? We always expand to at least 3 terms. So this is going to be cos squared 25 degrees. This can only be angle. Sigma means plus. Cos squared, we increase the angle by 1, 26. Plus cos squared 27 plus. Now always when the last term is known, do it as well. Cos squared 65 degrees. Okay. So this is essentially our series. Now this is a bit tricky, but if we look, there's a consistency here. There's a cos squared, cos squared, cos squared, cos squared. And we can see the angles are increasing by 1, right? So most likely, not to say it is indeed, I'm not sure, most likely this is an arithmetic series. Although it's very difficult to express what the common difference would be. It's not so easy. But let's just go for it. Sometimes you just have to go with the flow. What would be the number of terms? We take the top, we subtract the bottom, we add 1. So this is 40 plus 1, which is 41. So there's 41 terms in here. All right, now folks, how do we deal with this? We know that the sum of an arithmetic, when we know the number of terms, is going to be n over 2 into the first term plus the last term. At least we know what it is. So we've got S41, it's going to be 41 over 2 into the first term is cos squared 25 degrees plus the last one is cos squared 65 degrees. Okay, cool. So we just keep going. So S41 is equal to 41 over 2 into, now a further inspection, one will appreciate that 65 plus 25 gives us 90. So we can try to use our core functions here to move around. But first, this is cos squared of 90 degrees minus 25 degrees. Perhaps let's use round brackets. Right. Now we continue. S41 is equal to 41 over 2 into cos squared 25 degrees plus, this changes to sine squared 25 degrees. Now S41 is going to be equal to 41 over 2. Now we know that the square identity kicks in. This is equal to 1. So this means S41 is nothing but 41 over 2. Okay, do we see something like that? Not really. But what is 41 over 2? We see decimals, so we know that this is going to be 20,5. Right, so the answer becomes option C. Okay, so a bit of an interesting question on trigonometry using sequences and series, and of course along the way strategizing to maximize on our answer. All right, let's look at question 5. So question 5 says a sum of 2,000 rands is invested for 10 years and earns compound interest annually. So what do we know about annually, yearly, or every year? Okay, the final amount after 10 years, that's the period of the investment, is 3 scotos. Now, which expression represents the annual rate of interest? Okay, simple compound interest calculation from grade 11. So we know that the accumulated amount becomes our present value, 1 plus the interest rate to the exponent n. So we were told 3 scotos came from 2 scotos into 1 plus I to the exponent 10. Now the first thing that we do, we need to divide by the 2 scotos. This gives us a 3 over 2 is equal to 1 plus I to the exponent 10. Now the second thing that we need is to take the 10th root to get rid of that exponent of 10. But what we do on the one side has to be done on the other side with equations. So if I can just rearrange, this becomes 1 plus I equals the 10th root of 3 over 2. Okay, right, so we move everything around. So this implies that we've got I is going to be equal to the 10th root of 3 over 2 minus 1. Now remember, for I, it has to be a percentage. So whatever we've got here has to be multiplied by 100. Great, so that should be the 10th root, excuse me. So do we see something like that? Well, D looks like it, but it was further simplified, so we know that I could have been expressed as the 10th root of 3 over 2 is 1,5 minus 1. Okay, and the 100 was put in front instead. Remember, multiplication is commutative, so where we place the 100 doesn't matter per se. All right, so we can see that our final answer is option D. As you can see, folks, just simple things, simple actions, not complicated stuff at all. Now let's look through question 6. So question 6 says, in the sketch ABC and D lie in the same vertical plane with ground level BC. The angle of elevation of D from A is 30 degrees. So this is to say, if we're saying angle of elevation, then that means we need to picture some imaginable horizontal line. So this angle, that would be the angle of elevation. So we are told it's 30 degrees. Okay, if this is the angle of elevation, it means this is some imaginary 90 degrees. That's a vertical, isn't it? Now, in maths, folks, in this topic, we know this is the 3D structure, sort of. So we calculate all possible angles. In there, this should be 60 degrees because the sum should be 180. Now, this is also to suggest that this angle over here, must also be 90 degrees because this becomes a rectangle. Like this one will also be 90 degrees on this side. Okay, nice. Right, let's see. While the angle of depression of C from A, so that is if we draw or construct something, again, this is a construction, we break it up, is 60 degrees. So angle of depression, this is the angle right here. So this is 60 degrees. Now if that is 90, this angle should be 30 degrees. Okay. And if that angle is 30 degrees with this one being 90, that angle should be 60 degrees. Since these two are parallel, so these are alternate angles. So again, folks, in physics or in maths, whenever angles can be calculated, don't wait to be prompted. Now the first question is, what is the value of x? So we can see that x is over here. And we want to know, what is it? Okay, so this is quite a silly question, but let's see what can we do about it. I'm looking at this triangle. So I've got a side and I've got all the angles. So usually this is best to start with. But if I'm looking at this triangle, AC is somewhat common with this particular triangle. Okay, so certainly if we can use this as the common side, remember with this, again, in the other triangle, we will see that we've got 100, we've got a side, we've got all the angles. So with the common side, we can use that knowledge because we know to deal with those 3D, 2D structures, we tend to use a structure that we've got the most information and at least one side given. And we tend to work towards a common side. So let's try to use this. Now, if I'm looking at this triangle, I've got two ways. I can use cos, I can use sine. So whichever looks simple for you folks. So if I can say here, well, in triangle A, B, C, right? I can safely say sine of 60 degrees should be equal to, the opposite side is x, over the adjacent side, sorry, over the hypotenuse side, which is AC. But now I'm interested in AC, so this implies that AC is going to be x over the sine of 60 degrees. Right, but I can already see that I've got values, so I need to get rid of this. Okay, maybe let's not conclude just yet. So we know that AC is going to be x over sine of 60 is root 3 over 2 from our special angles. So therefore AC is going to be, this flips, becomes 2x over root 3. Okay, that's the first thing that we can do. We can say here then, if we look at the other triangle, in triangle ADC or ACD, we will see that AC is still there, so we can use it and say AC over, what do we know? Sine of the opposite angle, sine of D is going to be equal to, what would be the other side? We want the given side, so it's going to be CD over the sine of the angle DAC. Right, so this is the sine rule. So what do we know? AC is 2x over root 3. This is divided by sine of D. This is sine of 60 degrees. This is equal to CD, that's 100, divided by sine of 90 degrees. Okay, so this implies that we've got 2x over root 3. Okay, let's just keep it nice and simple. Sine 60 is root 3 over 2. This is equal to 100 divided by sine of 90 is 1. Okay, so this implies, of course, we multiply with this one flipped, so this becomes 4x. If you don't know how I did this, guys, icon. Hey, stop this one. Root 3 times root 3, that's 3. This is going to be 100 over 1. We cross multiply, we get 4x is equal to 300. Nice. So we know that our x is going to be 300 divided by 4. Nice and easy. Now folks, just be humble. Don't rush anything. You can just say, well, 300 divided by 4. So we can see 4 doesn't go to 3, so we look at 30. So 4 to 30 goes 7 times. To 28, 7 times 4, that's 28. We always subtract, so what do? We start with the units, so that's a 0, so we borrow there, we end up with a 10. 10 minus 8, that's 2. 2 minus 2, that's 0. We drop the last 0. 4 to 25, 5 times 4, 20. Now we subtract, this is 0, 0. So our quotient is our answer. So we can see that, therefore, x is 75. Answer B. Okay, so therefore our answer is option B. Okay, some questions can be quite a lot, essay type questions. Of course, in this topic, we know we expect a bit of work, right? Right, so let's look through question 7. So question 7 says, in the graph, the range of G is -1 is to 1. So this is to suggest that the maximum value is at 1 and the minimum value is at -1. Okay, cool. Now the question is, what is g of x? So we want the equation of g. What should this be? Alright, so we've got all these options, nice and easy. But now what can we look at? If we just look at this graph generally, this is sinusoid. Is it sinusoid? Sinusoidal, is it? Sinusoidal. It's like a sine graph. Let me put it that way because this word is not coming out okay. Sinusoidal. Yes, that's the word. Right. Now, a sinusoidal graph could represent two things. It could represent a cosine graph or a sine graph because these are cousins, right? So this could be the case. Nice and easy. Now let's have a look. How would this one be a cos graph if we say this is a cosine graph? Now, folks, we know that cos of 0 should give us a maximum. But now we can see our maximum has shifted some units to the left. Although we may not know what that is for now, we also know that this x-intercept should have been at 90 somewhere, wherever this is. But now this has shifted to the left so that it sits at 30 degrees. So we can see there's a bit of consistency. And we expected this again at some 270. You know, wherever this is. So we can just approximate. But we can see that that x-intercept has also shifted to the left, essentially some degrees. Now this is greater than 360. We don't want to focus too much on it. But now what is this? 270 minus 60 goes to 210. 90 minus 60 goes to 30 degrees. So this means our equation, or whatever this is, it must have been cos of, x. If we shift to the left, it's going to be plus 60 degrees. Right, do we see anything like that? This is certainly not. Okay, B is just saying sine alone. Okay, whatever. C, we have what we want. D is just saying cos 30 only. So we'll find out if what should have been the sine is the only one. Now let's see. If this is a sine graph, what should it be? Of course, I should just write g of x instead of just y. Now let's say this was a sine graph. So what do we know? A sine graph should start at 0 as an x-intercept. Now this has gone 30 degrees to the right. That's the first thing. Right. And this was meant to be at 180 degrees, wherever this is. But now this has shifted some degrees to the right. Now from 180 to 210, that's 30 degrees. So we can already see that this is shifting 30 degrees to the right. So we know that, okay, here we've got x. To the right, we subtract 30 degrees. That's the first thing. But now what is this? We know, folks, that technically for a sine graph, the one thing for sure is that in the first quadrant, that is from 30 to 90, we expect this graph to be positive. Now it's negative. So this means this is a vertical reflection of the graph, or a reflection about the x-axis. So we just multiply the sine graph by a negative. And that's what this one should be, and we can already see there it is. Okay, so this means C is our viable option because it covers both possibilities nicely. So for this one, it's just a nice walk. Answer should be C, as you can see how we worked through that option right there. Now let's look at question 8. Maybe we can squeeze it here. Yeah, there's still enough space here. So question 8 says, given the exponential function g of x is a times b to the exponent x minus p plus q, where b is greater than 0 and b is not equal to 1. Now the graph of g will have an x-intercept. So we're interested at the point where this shows us an x-intercept. Now folks, technically the horizontal shift will not affect much, ne? But what will is actually the the asymptote. So shifting the graph vertically will definitely do affect how we get things done. Now folks, let's just look at this equation on the Cartesian plane for various options. Now if we look here, we will appreciate that with this being the x-axis and the y-axis and the origin, the standard graph, when b is greater than 0 and, greater than 1, so this is when a is greater than 0, meaning the graph appears above the horizontal asymptote. We are actually avoiding the q at this point, and we know that b greater than 1, so this combination gives us this graph. It looks like this, okay? But now, when would we have a x-intercept? This can only happen if we shift this graph vertically down so that the asymptote or the x-axis are now negative. This is when q is negative, because in this case we get a graph like this, sort of. And we can see that we start to register an x-intercept. So this will happen when q is less than 0. So now the two things that answer the problem is when a is greater than 0 and q is less than 0, seeing that the options are talking about a and q. So this is valid. We have proven it, that it is so. But now there's more options to consider, folks. We can also look at a scenario where what happens when the graph is somewhat changed a bit. So this is x, this is y, this is the origin. Now what happens when a is less than 0, but b is greater than 1? So what happens? Now when a is less than 0, this says this is the graph that appears below the horizontal asymptote. If b is greater than 1, it says our graph is a decreasing function that appears below the horizontal asymptote. So that would be the graph. So this is our graph. Now when we consider the horizontal asymptote shifting, we can only achieve an x-intercept if this goes up here somewhere. So if our asymptote goes up there, then it means our graph is going to do stuff like so. Right. So essentially, we start to see that x-intercept when q is greater than 0. So q must be greater than 0 when a is less than 0 for this to be achieved. Do we see that? Yeah, that's number 3. Okay. But remember, folks, consider all possibilities. Do not rush. So let's have a look. What happens when this graph is taking a different format still? So we say x, we say y, origin. Now, what happens when a is greater than 0, but we've got b less than 1 but greater than 0? What happens? So what is this? Now we know that this is a graph that appears above the horizontal asymptote, but a decreasing function. Okay, so this is what this graph would look like normally. But then when would we see an x-intercept if our asymptote is put on the negative side, meaning we're shifting the x-axis there, because then the graph would start to do stuff like this. Of course, most likely this would be the first one, but sometimes if we shift further, that's what we end up with. So don't worry too much about where the x-intercept has to be. Is it negative or positive? It's immaterial. Fact of the matter is we have it. But now what is the combination here? Q must be less than 0. So do you see there is some consistency with a less than 0, so a greater than 0 and q less than 0, irrespective of what the function looks like, it still satisfies option 1 and 3. Okay, last one to consider. So take your moment here, don't rush anything, but make sure it's all good. So what happens when a is less than 0 and b is less than 1 but greater than 0? What is this combination suggesting? Well, we know that this is an increasing function that appears below the horizontal asymptote. So we end up with a graph like this. Right, this is what this graph would look like. All right. Now, if our asymptote is then put on top, that's the only way we can achieve an x-intercept. So this graph would look something like so. All right, depending of course on where this intercept starts to show. So we can see that when a is less than 0, q must be greater than 0. So again, there's a consistency in this case. So obviously, folks, our option now becomes 1 and 3. So that's C. Okay. So review this. Of course, you don't have to go through all this trouble if you know this, well. But if you don't have an excuse not to go through all the trouble. All right, so let's get to the next question. So we've got question 9. So question 9 says, in the figure, a square is symmetrically located in a circular target, okay, of radius r. A dart is randomly thrown at the target, hitting it. What is the probability that the dart landed in the hatched region? Okay, so you can see the hatched region is those segments where the chords are the sides of the square. Okay. Now remember, this is a circle, so a circle will have a center somewhere, right? And if this is a square, we know that the opposite angles are equal, 90 degrees, right? Right, so this already tells us that, we can actually draw ourselves a diameter there through the center. We know those are angles in a semicircle. Even if we draw another diameter that way, it's fine. But now we know that if this is r, this is also r, okay? But now we know that the sides of the square are equal. So this is a regular polygon. Now a regular polygon in the sense that all sides of this quadrilateral are equal, as well as all the angles are equal. And what is the other property of a regular polygon is that it is inscribed inside a circle. So it is cyclic. A regular polygon is cyclic, meaning there's a circle drawn around the vertices, or should we say through the vertices of that polygon. So these are the things, folks, that need to sit in your head. One needs to know this. I think we learned about inscription of, figures inside others in grade 9. I don't know if you're still being taught these things, folks, but yeah, anyway. Whether you are being taught or not, I'm teaching you now. Yes. Right, so what do we see now? Well, if we're looking at the probability that something lands in the hatched region, it means we need to find the area of the hatched region against the area of the entire circle. But now how will we do it? If we look through the options, we see pi and root 2 pi, but there's no r. So we need to play a very long game now. If we look at this structure like this, if we look at that right-angled triangle, we know that the sides of the square are equal. So we can already try to somewhat find the side of the square in terms of r, because that way we can also use the area of the circle in terms of r. So this makes it all nice and easy. So we know, folks, that basically 2r all squared, remember that's the diameter squared, must be equal to the side squared plus the side squared from Pythagoras, seeing that this is a right-angled triangle. So we get 4r squared is equal to 2s squared. Therefore, we know that s squared is going to be 2r squared. So therefore, our side here is going to be root 2 times r when we take the square root. Nice and easy. So that's the first thing that we need to do. Second thing, what are we looking for now? We want the area of the hatched region. So we can say, well, area, or should we say the probability? I think let's just go straight to the probability and just do it in one single step. We can say here then, we know that the probability of any event E occurring is going to be the number of ways in which E occurs over the number of outcomes in the sample. Now we can see that the hatched region is going to be the area of the circle minus the area of the square, right? All divided by the area of the circle. Now let's get to business. So this is pi r squared, excuse me. And the area of the square is the side squared. So this is root 2 times r all squared, all divided by pi r squared. I don't know why I'm incomplete in my thing is. Now folks, we've got pi r squared minus, this becomes 4r squared, all divided by, did I say 4? Excuse me, root 2 squared is just 2. Okay, now this is pi r squared. Now with this, we know that the denominator is divided into each term of the numerator. So this is going to be the case. So please guys, don't flinch when it comes to these very basic issues. We can see r squared takes r squared, pi takes pi. Here r squared takes r squared. So we end up with just 1 minus 2 over pi. Now we see that our option A here is our friend. Okay. Nice. So again, quite a silly question where one has to consider quite a few things, make some constructions. Don't shy away from making constructions. But note, a square is a regular polygon. Why? All sides are equal and all angles are equal. And thirdly, this essentially is inscribed inside a circle such that its vertices are at the circumference of that circle. Or one can say there is a circumscribed circle to a square. Nice and easy. Now let's have a look at question 10. So question 10 says, if CD is 2, DE is 5 over 8, and CE is equal to 20. What is the possible value of CDE? So this is just a product. Okay. Now if we start with CD is equal to 2, we can say therefore C is going to be 2 over D, right? Nice. Same light, if we look at CE, for example, CE is equal to 20. Now we know that C is basically 2 over D times E is equal to 20. So we can already see that E would be D times 20 is going to be 20D divided by 2. That's 10D. Okay. That would be it. And then we can come back to DE. We can say here then DE is equal to 5 over 8 implies, now let's see, D is just D, but E is 10D is equal to 5 over 8. Now this is going to be 10D squared is equal to 5 over 8, excuse me. So easy to write things incorrectly, folks. Always stay alert. So this implies that D squared is going to be 5 over 8 times 10, that's 80. Now if we simplify this further, D squared is going to be 5 goes once and goes 16 times, right? Please know the things, folks, and then we take the square root. When we take the square root, we know that D is going to be plus or minus 1 over 4. Okay. Nice. Now, we've got the value of D. So what is the story now? This would mean that C is going to be 2 divided by plus or minus a quarter. Therefore, C is going to be plus or minus, this flips, it's going to be 8. Therefore, the same applies for E. So now if you multiply this by a quarter, that's going to be 5 over 2. So it has to be plus or minus 5 over 2. Right. Right. Now we've got all the values of C, D, and E. Right. So let's do the things. We can say this implies that C, D, E is equal to, you can just say plus or minus C. What did we get? 8 into D, which is plus or minus a quarter, into E, which is plus or minus 5 over 2. Okay, cool. So obviously 2 goes once, goes 4 times, and then 4 and 4 take each other out of the mess. So C, D, E is, now folks, this is going to be just 5. Again, this is plus or minus 5. Okay, so if we look through the options, option C is minus 5. So we can say here, therefore, C, D, E is minus 5. Therefore, our answer is option C. Now, under these circumstances, it tells us that all these values that are valid here are these ones, the negative values, technically. But again, one can just do the calculation like that and just look for the solution. Okay, that was an easy question. Some people say this is solving by substitution, right? Yeah, because there's not much to do with this. But if we had more than 2 terms on one side, we could talk about is it the Gaussian or the Gaussian elimination technique. But this one allows for a substitution method. of simultaneous equations. Question 11 says, if f of x is equal to 4 minus sine 4x times tan 2x equals g of x is equal to m, where m is a constant. Okay, cool. Now, for which values of m will the graphs of f and g never intersect, meaning non-real roots? Okay, but f of x is quite scary, so let's deal with f of x. This is equal to 4 minus sine 4x times the tangent of 2x. So let's deal with this. So this is 4 minus, this is as good as 2 sine 2x times cos 2x times tan of x is sine 2x over cos 2x. All right, so this guy and that guy goes. Now remember, with rational expressions, the moment something divides to 1, it already tells us that there is going to be a hole in this graph, a point where this graph is not defined. That's a hole, as opposed to an asymptote. So that should come to mind. All right, so let's keep going. So we've got 4 minus 2 sine squared 2x. But now this looks like our compound angle identities. So if we think about it and say, well, what about cos 4x? This would be 1 minus 2 sine squared 2x. All right. How about we isolate this one? We know that minus 2 sine squared 2x would be, right, we transpose this, it's going to be cos 4x, not minus plus, but minus 1 when we transpose this to the other side. Okay, please guys, be capable of playing a long game sometimes. Now this is to imply that we can say this is 4 plus into minus 2 sine squared 2x. Now the skill of simplification, guys, will horrify you if you don't know how to play with the signs. Now what is this? If we replace this with this structure right here, we are good. So this is cos 4x minus 1. Right. Remember, we don't draw graphs of squares of trig ratios. We only want the exponent to be 1 for the trig ratio. Okay. So if we simplify this further, we know that this is cos 4x plus 3, excuse me. So this is our function f. Now we know we can picture this on the Cartesian plane, right? Yes, of course. So if we picture this on our Cartesian plane, what seest thou? Thou seest theta. Is it theta? No, theta, whatever that is. Great. So we know, folks, that our maximum is going to be 3 plus 1. That goes to 4, right? And then our minimum is going to be minus 1 plus 3, which goes to 2. We can put it over there. So our graph is going to oscillate over here. Since this is a cosine graph, so it's going to do stuff like so. Don't worry about the graph looking strange. It's not going to look the best. Right. Soon papela. Scampapela. Ooh. Chavo Guerrero. Right, folks, so this is roughly the sketch, okay? Of course, we're going to have many graphs because the period is so much smaller. Now, this is literally what the graph is doing. Now, folks, we know that one of these values would be a whole, isn't it? Why? Because we see that we divided by some cos 2x. Now let's check. This is possible provided cos 2x is not equal to 0. So that would be the case when we have that as a whole. Now let's see, what is this whole situation? Cos 2x is equal to 0, not equal to 0. Means 2x must not be equal to plus or minus arc cos of 0 plus k 360 degrees, where k is an element of integers. Now, what seest thou? This is 2x is not equal to plus or minus arc cos of 0 is 90 degrees plus k 360 degrees, where k is an element of integers. Now we can already see that x is not supposed to be plus or minus 45 degrees times k 180 degrees, where k is an element of integers. Now that's the situation. Now considering k is 0, this would be plus or minus 45. Now let's see what is the case in this scenario when the angle is 45. Now 45 by 4 is 180. Cos of 180 gives us a minimum. So this means this would be a value at the minimum. Now that value at the minimum, as I said, is going to give us a whole because that expression kind of divided out. So a whole becomes an open thing like that, meaning that point is not part of this graph. All right, so this means all these minimums, because all these multiples repeating over 180 degree periods, are going to continue to be wholes. Okay, all right, okay. So this would be the case here as well. All these minimums are going to become a whole because they repeat at over intervals of 180 under these circumstances, right? Right. Now, folks, so now this is to say, technically, this function cannot be equal to 2. But it should definitely be equal to 4, right? So if we look at our g function, the g function is just a horizontal line. So we know that, well, if the horizontal line passes through here, satisfies the condition that we are exploring. If it passes through the whole, remember the whole is where the graph is still not defined, so that would be good, right? And if the graph, remember now the maximum should not be because this one is included, so the graph should be out over there. So if that's the case for m, remember these are the values of m. So this is when m is greater than 4. This is when m is equal to 2. This is when m is less than 2, literally. Okay, so this is what we have. So when does this not intersect our function? It's when it passes through the whole or below that or above the maximum. So this is to say, therefore, m must be less than or equal to 2, or m must be greater than 4. Do we see something like that? That's option C. So we can say, therefore, our answer is option C. Nice and easy. So obviously, folks, probably wouldn't know about this, most of you, because you probably have not been taught rational functions as yet. But if you think about it, on trig identities, you always get asked, for which values of x is this not defined? That's exactly those areas that would give a whole for the final function, if that can be simplified into a single trigonometric ratio. So that's just the idea. Okay. Ria tswella pele. Re tswella pele. Question 12 says, the following was recorded after a maths test in grade 12 at a local school. Okay, minimum mark was 50%, range was 50, that's a measure of spread, standard deviation 5, that's another measure of spread, median, that's a measure of central tendency 45. Now the question says, it was agreed that every student is awarded an extra 5 marks. So we need to find the new sum of the mean plus the range plus the standard deviation plus Q2. So what happens here? Well, I know that the mean, if, remember a measure of central tendency, when we increase the individual values, it will also increase by the same amount. So we know that if x was 50, it's going to now increase to 55. But the measure of spread, if we increase each individual data point by a particular number, this doesn't change, so it remains 50. Again, all measures of spread, if we increase every data point by the same amount, they literally remain the same. So the standard deviation will also remain 5. But measures of central tendency will always increase by the same amount that the individual data points increase by. So this is going to be 45 increasing to 50. Now folks, we can see that this is 100 plus 60, that's 160. So the answer becomes option B. So this one is as simple as that. Right, so yeah, for this one we don't want to complicate anything. So the answer is just B. Nice and easy. Obviously, just know that measures of central tendency, when all data points increase by an equal amount, those values will also increase by the same amount. But when it comes to the measures of spread, they certainly do not change. That's just the one idea that needs to ring bells into your head. But remember, guys, you're not going to read this in a book, so to speak. These are things you need to realize. Remember, you're not learning to be told everything. We teach you basics, and you have to realize the implication of those basics. Even the trends within those basics is something that a student who is learning needs to open their mind to realizing those realities or those truths. They can't always be spelled out to you. Because I see a lot of guys going around on social media and everywhere else saying this education system is weak, it's failed, they're trying to compare us to other countries. We are not in those countries, people. Stop talking nonsense here. At the same time, those environments are hostile to those people. As much as they seem to work on the outside, those are hostile environments where young children are made to do manual labor, all in the name of that they have to be high-tech. Yes, they are, but they become dangerous anyway. Because you see, if you learn a skill that you don't know its purpose, you will always use it the wrong way whenever it suits you. Because the very same countries that we claim are the best in everything, they are the most dangerous. They cause chaos all over the world. Wars are fought because of such people. Because they use this intelligence the wrong way, because now kids start to realize how dangerous they can be with all of this knowledge, instead of using this knowledge to uncover more secrets that make the world a better place. So at the end of the day, just stop with this nonsense of obsessing over what other people are doing. You can copy what is good, but there's no need to try and copy everything. You certainly are not the same people after all. God created variations of humankind for a reason. We should not necessarily do the same thing, all of us. Otherwise, the world becomes very much hostile when that happens. There has to be someone on top and someone below. Okay, right. We can't all be bosses. It's not going to work. That's why God gave those specific gifts to certain individuals, so that those ones can be at the top of the food chain, and then others must follow those individuals. Remember, without a leader, all societies break down. And not everyone can lead. As much as everyone may have ideas of how to lead, none of them can have, the ability to truly lead. They can only imagine what leadership is all about, which is exactly what we hear on social media. People criticizing leaders, talking nonsense as if they know what leadership is. If you go back to their very own families where they come from, they have no leadership role whatsoever. They are just loons who are even ignored by their own. But they want to come here and become relevant. How foolish. Anyway, let's not get to such crazy stuff. But anyway, it makes me angry though to listen to mindless chatter by many people who talk from a point of ignorance than anything practical and tangible. Right, let's not talk, let's do. Ons nie praat hier soms, ons doen. Wij skende. Now A, B, C lie on the circle, so these are what we call concyclic points. Those points that lie on the circle or on the same circumference, we call them concyclic. Now there's an implication for this when it is given. Think of a triangle on a circle, so a cyclic triangle. Now once you see that, you think of a 10-chord theorem, because somewhere, somehow, one of the vertices is going to be, a point of tangency. And of course, if you see again concyclic points, you see more than 4 points. Some 4 points might form a quadrilateral, in which case that becomes a cyclic quad. So always have these terminologies in check, otherwise you become a joke in maths. Now with the center M and radius R, okay, cool. So that's the center. And we know that the radii are equal. If one is R, the other one is also R. Maybe let's make it nice and easy to see, right? Now we're told also that ABC is isosceles with the base BC. Can you see the base is specified? Don't always assume the base. Yes, technically from, the lower grades, we assume that the side adjacent to the angles that are equal is the base. Yes, that's true. That would be the definition of a base for an isosceles triangle. But what if I get confused? Because technically in maths, we prefer to speak only what is true and what cannot be distorted no matter what. Hence, we use the angles opposite the equal sides, because that will hold true at all times, irrespective of what the basal side is. Because remember, the basal side of any figure is the side it sits on if pictured put on the ground. Okay. But now what if the other side is not the one of the two that are equals? Then what do you say? You are simply talking nonsense, right? Yeah, you just have to take it on the chin. Stop crying about nonsenses that you engage in and you don't want us to talk about them, hey? We're going to tell you the things that we can see about you. Yeah, not because we hate you, but because we love you enough to tell you the truth and fact. You just go with it or you cry about it. Is up to you. All right. So if this is the base, folks, this already confirms that, hey, these ones are equal. And we're also told that AC is M. So if AC is M, that means AB will also be M. Now BMC, this is this angle over here. This is 60 degrees. Now obviously from angle at center, 2 times angle at circumference. So this one must be 30 degrees. Right. Cool. So the shaded region is given by, okay, the shaded area, excuse me. So if we want that, so this is obviously going to be area of the big triangle minus the area of the small triangle. That gives us the area of the shaded region. So we can use our area rule here. So we know that area is going to be half. The big one is going to be AB times AC sine of angle A minus half BM or MB and MC sine of BMC, right? Using the area rule. This is equal to 1 over 2. Now AB is M. That's also M. Sine of A is going to be 30 degrees minus 1 over 2. This is R. That's R. Sine of 60 degrees. So this is a half into M squared. Sine of 30 is a half. Minus 1 over 2 into R squared. Sine of 60 is root 3 over 2 from special angles. Now let's get to business. So this becomes M squared over 4 minus, this is root 3 R squared over 4. Okay. Right. Do we see anything like this? Okay. So this is factorized. So we can do this. So we can take a quarter out. When we take a quarter out, what happens? We get M squared minus root 3 R squared. So this is option A. Okay, this one is not too complex, but it helps to remember the theorems and the rules of triangles in trigonometry. Okay, let's look at question 14. So question 14 says x squared is equal to 17x plus y. Y squared is equal to 17y plus x, where x is not equal to y. So we don't know why this is being put. We will see. Now we need to evaluate the square root of x and y. So the immediate thing that comes to mind, simultaneous equations, because we've got y here and then there's y also in this one and that one. So how about we write these and say x squared is equal to 17x plus y. If we isolate y, we're going to say y is going to be x squared minus 17x. Okay, cool. And then we can say and y squared is equal to 17y plus x. So this implies where we substitute y, we get x squared minus 17x. All squared is going to be 17 into x squared minus 17x plus x, excuse me. Okay, substitution method. The moment this goes to exponent 4, it causes us problems. Even if we try the K method, it would still not work because this one is all alone. So when this one is all alone, it's going to cause us problems, is it not? I think so. But we can, to some extent, and decide to make but it's not going to work, because if this is all alone, my only worry again is that these numbers are going to be too big to evaluate without a calculator if we get an equation like this. So most likely we don't have to solve for x directly, so we can just say hold the thought. Remember, substitution method is not the only way to solve simultaneous equations, but we know that once we've got terms, we can use the Gaussian elimination technique. Wow. Now let's say this is x squared is equal to 17x plus y, and then we call this one equation 1. Now this one says y squared is going to be 17y plus x. That's equation 2. How about we say 1 minus 3 Yes, so this is going to be x squared equals 17x plus y. This is trial and error, by the way, folks. Hey, you never know the answers sometimes. But you just try. So abandon a potentially difficult problem before it causes damage and time wasting. If we say x minus this is going to be x squared minus y squared. This is going to be 17x minus 17y. This is going to be plus y minus x. I can already see a pattern developing here. Got a difference of 2 squares. If I factorize it, it's going to be x minus y into x plus y equals, take out the highest common factor, factorization by grouping. I get 17 into x minus y. Can you see there's an x minus y there? Even here, I can decide to take out a negative instead. It's going to be x minus y inside. Now, this already highlights what was this all about, is to suggest that this bracket is not equal to 0. And if that's the case, it means we can divide throughout by it. So if we divide by x minus y, what do we get? We get x plus y is equal to, hold it. Okay, that's going to be 17 minus 1, which is going to be 16. Hey, why would casual? Because this would be 17 minus 1. I mean, if we divide by this, it's going to be 1. So that's 17 minus 1, that's 16. So we can say then, can you see this was an indirect one? We know now that the square root of x plus y is going to be equal to the square root of 16. Which is equal to 4. So the answer is option C. Hey, what a sharper one. So can you see, guys, you abandon one thought, it unravels. Is it unravel? It unravels. The truth, in fact, the truth. Even the restriction now starts to make sense. Because not one way sometimes works. Sometimes the other way is the only way. But maybe there is a way of making the first one work, but probably without so much fun, eh? Because some techniques become horrible. And remember, it's all about strategy sometimes in these exams. It's not about your endurance. Nah. Sometimes it's how smart you are. Smartness is a measure of how efficient within reasonable time you can be. Yeah? You can't give you a whole week to solve a problem and then you claim you are good, you are bad. Even if you come up with the solution, you're terrible. But when you're a student learning, you can do it. Who cares? Ain't nobody does. Duh. That's what the ladies say when they want to be silly. And you want to slap them across their face to stop the nonsense. Because that irritates the hell out of me. But yeah, you don't slap them. Yeah, you don't slap them. You don't slap them. Or you will be slapped by life. Okay, guys, excuse the noise. My dog needs grease. It's terrible. All right, let's look at question 15. So question 15 says the graph of f is equal to sine of x plus m. For constant m is shown. Cool. P 120 is to 1 is the turning point. So this is the maximum. Right, so this is at 1. Okay. Of f, right? So g of x is root 2 over 2 of sine x plus cos x. Now the question is, what is g of x? Obviously, I don't know what that means. I looked through the options to find out what am I supposed to do. This is a transformation of f. So the question is, what is f in the first place? So if we look at f, this is the sine function. Now the sine function must start at 0. Now it moves through the right so that the x-intercept is this one. Okay, that's fine. But this maximum now is at 120. But for the sine function, I expect it to be where? At 90, maybe 90 over there. Let's say this is 90. This is 120. So we can already see that we truly moved to the right some units. So what's the difference here? 90 to 120 is 30 degrees. So this is to say, well, f of x is sine of x minus 30 degrees, isn't it? Nice. That's what this means. Okay, all right, okay. Now let's look at g of x. G of x is root 2 over 2 into sine x plus cos x. We can already see compound angle identities kicking in. If we FOIL this out, it's going to be root 2 over 2 sine x plus root 2 over 2 cos x. So g of x is, remember this is 45 degrees. Now multiplication is commutative, so this is as good as sine x cos 45 degrees plus, we can say cos x sine 45 degrees. Now we know that this is the sine compound angle identity. Nice. So this is g of x. Now if we compare these two, how do they relate to each other? We've got minus 30 degrees. Now all of a sudden we've got a plus 45 degrees. So obviously from minus 30 to 45 we must have added 75 degrees. Yes. So this is to suggest that therefore g of x must have been f of x plus 75 degrees. That becomes option D. Ne? So in this case, this is to say we take this value and we substitute for the value of x over there. So this becomes x plus 75 minus 30, which lands us at x plus 45 degrees. Again, folks, there's a video I gave you in the video section of this channel. That video, I showed you guys how functions work. So please know these things, and again throughout the channel you'll see that questions on trigonometric functions have been given with some detail put in it. So again, this helps to build your strength in this subject. But yeah, at times it may work, at times it may not work. Just depends on how well you take the exam. Alright, so could we squeeze this one? I think we can. Question 16 says, the diagram shows the graph of h, okay, if f of x is x squared, so this is the standard parabola, so stuff like so. Right, so this is the stuff that we're talking about. Passing through the origin, which of the following could represent h of x? Then if h of x is related to this is some transformation. Now, for example, for this to be concave down, so what must have happened? We must have reflected the graph of f about the x-axis so that it looks exactly like that, right? From there, we then move the graph to the left some units, because from here, then move to the left some units so that the turning point is some like that. And then of course we then have to move it up, you know, stuff like this, stuff like this, you know, stuff like swa. So essentially we did a vertical reflection, a horizontal shift to the left and a vertical shift to the right. So that's what we did. We did the flip. And then we moved the graph to the left, these units, to that axis of symmetry. And we then moved the graph some units up to that maximum turning point. Okay, so a horizontal shift would mean we put a negative in front of the function. That, and that. So this is already wrong. Yeah, stop order for what, people? Sanuthathi imali nina entweni zami. 1,500 Metropolitan. Qela kabi. Thatha imali yokwenzani inhloko zenu. Xa senifuna ukuclaim apha banixelela izitori labadoti. In fact, ndiyaziyeka zonke ezi policies eziphambeneyo. Nona imali yami le ndiphisa ngayo ezi zitunqa ndiyibeke, ndivule i-account qha. Ndihlale le mali so xa ndiyidinga ndiyisebenzise. Le nonsense yokuthi mandivelelwe ingxaki nandibe ndiyocenga ezi zibhanqa ngemali yam ngephofu ebendiyiluza inyanga nenyanga mna ngelithi bazondinceda. Next thing bandenza i-criminal. Sefuna ngoku nabandijonge kuqala ele ndidinga ngoku imali andixa babana basenza investigation yabo ne-processing. Kodwa imali yam bebeyithatha bengakhange badinga ukuprocess uba banyanzelekile ukuyithatha or not. Hey guys, yekani udlala ezi scams zodoti be-insurance. Nonsense yonke le nto le. Ewe bakhona abanethamsanqa bancedakale but nabo abancedakali ngendlela abanqwenela ngayo ukuncedakala. Ihlala yonke le nto inobudenge phakathi. Kanti xa unemali yakho uthatha into yakho isapho udinga uncedo. Kodwa ke mandikuxelela inyani ngaphezu kwayo yonke into. Apha emhlabeni akho nto ingakunceda ngokupheleleyo ngokwayo. Uphinde udinga abantu abanengqondo ukuze uncedakale. Ngoba noba ungathi unemali uhambe uyobhatala uhleli ungabhatalela umoya. Ndiye ndalungisa imoto yam apha ngoFebruary. Ndiye ndabhatalela umoya bantakwethu ngoba ndithe ndiyoyilanda imoto emarket kwa-VW. Imoto yam ayihambi, icima endleleni, icima nje lapha ePort Shepstone. And okwesibini yayenza ngoFebruary phinde yayenza ngoMeyi xa bendiyoyilanda. That means ndiye ndabhatala nje 40,000 yam for mahala. Ndiphisile nje ngayo. Okwesibini ndifumanisa into imoto yam bayityhuthulile. Ayisafani nakuqala. Izinto endandiyiseyinazo ezisebenzayo azisasebenzi. Seyinengxaki ezintsha kodwa ndibhatele 50,000 for izinto abathe bazilungisile. The worst part, i-breather pipe yam pha babethe bayireplaceile intsha. Xa ndifika bayibophe nge-sellotape sana kodwa ndiyikhokhele. Yho, lumkani nizodliwa niphila zezi zintsha zabantu abathi bayanceda. Nangoba unanto ongayenza ngento efuna ukuyi-owna uvele uyiyeke. Vele nje uyiyeke. Okay guys, wasithethe nge-maths anyway. Now we've eliminated option C. So the second thing is we move this to the left. So any movement to the left is going to be a plus something. So already that's out. So it has to be a plus something. Because of the negative, that option is out. Poma, phone. Last one. Again, it can't be a negative to move it up. It has to be a positive, but because this is out, this is good. So that means this is option D. So here it's just a matter of knowing how to trace things. You must trace things. Things. Transformations. We've been preaching about it enough. So if you don't know it, well, go away. Don't come back here. Right. In the given triangle ABC equals the tangent of 3/4 and sine B is going to be 5/13. Thank you very much, comrade. What are you trying to tell us? It says, what is the value of cos C? Okay, cos C is going to cos the things, must. It's going to cos the C, must. Is that the cos the C? Can you eat the C? No, you can't. You can't park the car there. You can't park the car there. So strategy. What doest thou thither, or thither? Well, what we can do here, we can try to cut the triangle into two little triangles so that we can talk. But the cut is such that this is 90 degrees, also 90 degrees to the other side. But because this is something that we are doing which was not here, it must or can be. Cut. You see, mos, these people are taking mula, mos. Next, why is it taking money, this stupid thing? Because anti tracking device nje. Hey man, ngaqhela that bayikhuphe lento yabo. Hey kodwa guys, ukuqhelwa kabi yazi. Ndiyakuxelela. Kutheni futhi imali yami izoba ncinci kangaka? Hayi man, ngaqhelwa kabi apha. Unetstar wantoni lo? Iyaphela imali yami Nkosi. Khona nje imali ezithathwayo ndingazaziyo bazithathelwa ntoni. Hey, don't sign up to these things, people. You'll lose money for nothing, like nothing. But anyway, folks, sign of A, if we draw this triangle, so we'll see that this becomes now a right angled triangle. So if this is tangent, now remember, this is a ratio. Don't make these units. Careful. So this is the tangent is opposite of adjacent. So this means this is 3. Make it 3A. Then the adjacent side is going to be 4A. Don't make the mistake of not doing it like SWA. Now from Pythagoras, this becomes 5A. Because 3A squared is going to be 9A squared. 4A squared is going to be 16A squared. 9 plus 16, 25. Square root of 25 is 5. Square root of A squared is A. Thank you. Then sine of B is 5 over 13. This means, so technically this is a right angled triangle as well. Sine is opposite. So this certainly says 5. This must be 5B, right? Over hypotenuse, this is going to be 13B. Again, choose some multiple because this is a ratio, not units per se. So it could have come from anything. So avoid doing that. Now, can you see what happens? At the center, we actually can replace, for example, B by A or A by B because that's the same line. It can be looked at in terms of 3A, can be looked at in terms of 5B. Again, folks, from Pythagoras here, this portion, what does it become? 13, 169. 5, that's 25. 169 minus 25 gives us 144. So square root of 144, this is 12B. Okay, so again, folks, you can suffer if you want, but if you're smart, you're going to do smart things. So at the same time, I need to look at this nicely big red triangle. So with this one, we know that the cos of this angle is what we're interested in. But what is that angle? From sum of 3 angles of a triangle, this angle, C, is nothing but 180 degrees minus the sum of A and B. Wabona jwale, wabulela. You are talking. Wabula sweswe. Yeah. Nikutwisisa kahle man. Wabula man. Wabula. But now talk. What can we say? We know that well. Cos of C is equal to cos of 180 degrees minus the sum of A and B. Same function, so cos in the second quadrant is going to be minus the cos of A plus B. Cos compound angle identities, this is minus into, this is going to be cos of the first angle, cos of the second angle, sine minus, sine of the first angle, sine of the second angle, yeah, minus into cos of A. If we look at that red triangle or pink, whatever that is, cos of A is adjacent over hypotenuse, so this is going to be 4 over 5. Forget the A's, they divide to 1, so times cos of A, don't wobble, cos of B, man. Now cos of B is adjacent over hypotenuse, this is going to be 12 over 13. The B's go away if we're using the other triangle. Minus sine of A. Sine of A is opposite of adjacent, sorry, opposite of hypotenuse, that's 3 over 5. Again, the A's go away. Then sine of B was told to us that it's 5 over 13. Again, you can also look at the sketch. Now let's get to business. What is this? So 12, okay, by 4, that's 48, divided by 5 times 13, that's 65, minus 3 times 5, that's 15 over 65. Nice and easy. So minus into, now we can see the denominator is common, so this is 65. So we literally have to take 48 from 15. Now 8 minus 5, 3, that's 33. So the answer is minus 3, 3, 6, 5. So sigbonile, the answer is B. Of course, folks, there are many ways of killing a cat. As long as the cat is dead, we are happy. We are celebrating. So we are done with this one. Next, this is Oqeba, guys. I'm going to do only the first 20 and then on a separate video do the next 20, just to avoid tiring you up with a lot of things. Now P and Q are the respective maximum and minimum values of the expression into 3 sine theta minus 1 all squared plus 2. Now we need to find the sum of the maximum and the minimum. Okay, folks, first of all, you now must focus onto the bracket. You see, if we look at the bracket, what do we know? It is a perfect square. Now perfect square is greater than or equal to 0. Ooh. Sigbonile. So that is greater than or equal to 0. Now, this being the case, it means the smallest value this thing can take is nothing, right? Nothing. Okay, all right, okay. The other thing, okay, let's take it nicely, guys. We know that when 3 sine theta minus 1 all squared, this thing is less than or equal to some value, we don't know, but certainly greater than or equal to 0. The reason you know that's going to be less than or equal to something is because you know this is a function on a Cartesian plane. So a sine function has a maximum and minimum. You know most. So this is already telling us that this is going to be oscillating between some values of some sort, right? And we can already see that the final thing is such that the 2 is the 2 there. So that's why we know that it's going to be less than something but greater than something. So that's the first thing. But now what would be the big value here? Now the big value will come from the biggest value we can get here. But now if we look at the range, or should we say the domain, but let's just say the range of 3 sine theta minus 1 is going to be minus 3 minus 1 is going to be minus 4. Minus 4. And this is going to be less than or equal to, this one is going to be 3 minus 1, that is 2. So since this is a perfect square, can you see this will give us the biggest value? So if we square this thing, it becomes 16. Because this one is the small one, you see, we can't use this one. Okay, so this is a bit of crazy stuff. Sometimes some problems you can't just solve generically, you just solve in part by factoring a lot of crazy material in there. So folks, we can see that, okay, this one is like this. So this implies, remember with an inequality, we can add anything. So we want to add the 2 there. So this is going to be 0 plus 2. Sesigbonile. So this implies that 2 is greater than or equal to 3 times sine theta minus 1 all squared less than or equal to 18. Now we can already see, guys, the biggest value is 18, the smallest value is 2. That's the minimum. We can then say then P plus the QE, P is the biggest, 18 plus the smallest, 2, must 2 can be equal to 20. Mathematics is mathematicking, is palatable, is ngamos. So folks, if you don't know things, you don't know how to solve problems, you don't know how to look at things, at times it's not a smooth sail where you can just solve nicely algebraically. You solve jumping around using logic. I said it. Logic must always logic. Flawed logic or false logic or pseudo logic like that of politicians in this country and many other social media experts who have pseudo logic, talking nonsense to the whole nation and the world at large, showing how stupid we are. Makes me angry and itch under my armpits. I want to kill somebody. I'm joking, guys. I cannot. I don't even crush a cockroach on the floor. I just try to coach it away from the house. I don't like to kill anything. I can't do it. I will not do it. It must not be done. Okay? I'm even struggling to slaughter a chicken now. And yet when I was small, it was the most impressive thing I wanted to do. I never thought about this thing as alive and deserving to live freely without interfering by me or anybody. But hey guys, for survival we gotta eat. But if you think about it, man, how would I feel if it was me who now faces the knife, someone to eat me? Guys, I think this profession I chose makes me a freaking crazy individual. You know? Makes me... I really don't want to slaughter anything. Anyway, folks, we're doing question 19. Okay, my writing is also starting to die. It says now points A, B, C are collinear. They belong in the same straight line. Which of the following equations is correct? Alright, so one represents M, the other one N, N. So most likely this one is wrong because there's a consistency of N, so probably all the N's, but you never know, eh? You never know. So let's see, with collinear points, we know that the gradient between them is the same. So we know that our MBA is equal to M BC, for example, if we choose to do so. Let's see, MBA, that's going to be y at A, that's 6 minus y at B, that's N, divides x at B, that's M. Hey, hold it. That's 4. Hey, ungeta. Minus x at B, that's M, equals the gradient for BC, so we can say x at C minus 3 minus N divided by 10 minus M. Okay, so we've got a situation now developing here, so we can cross multiply. So what do we see? 6 times 10 is going to be 60 minus there are no squares here, guys. Okay. Yeah, 6 times this is 10, then minus 6m, okay, then minus 10n, okay, plus mn, okay. This is going to be equal to, now let's see, 4 times this is going to be minus 12, minus 4n, plus 3m, plus mn. Sikubonile wena nawe. Wena na. You dance out of the competition because you are weak. Okay, the weak ones must just go away. They must just go away. Right, minus 10n minus 4n. If we bring in this one, we get minus 6n equals 3m. We bring the other one is going to be 9m. Then we bring in 60. This is going to be minus. Now let's see, 60 minus 12 is going to be minus 72. Ke tsona tseo ha re divide ka minus 6n we rahalang re kry-a hore n o tlo ba minus 9 over 6 is going to be 3 over 4. Hey, when orange jwale now man 3 over 2 ska re thetsa man m minus, it will be minus, no, it will be plus. 72 divided by 6. Konje 72 divided by 6 ngubani kaloko ngubani 10 times 6 is 60 mos 12. Yeah, it's 12 times 6. This one is 12. Hi, it's wile man. Hi, it's wile ha ke sa batla lo sheba hore tse ding di batla ho reng. Ke tshepa hore di bua ntho e tshwanang wa bona. Empa emanyana. Oh yeah, yena fela hai bue nnete. E batle e ba haufinyana. This one is close, but the problem is this, you see. It was meant to be minus 3. When we move it to the other side, it must be a plus 3m. Then we cross multiply the 2 there, it becomes the 2n. Then the 12 remains like this. So the problem is just that small nyana glitch. Now this is 8. That's it, Bafwetsu. That's it, Bafwetsu. Therefore, our answer is B. Okay, just the knowledge of collinear points, guys. Gradient is the same. Now let's do the last one, guys, and call it a night. Let's leave some space for you guys to write some extra notes if you want. But remember, notes must not be reproduction of what you see. It has to be something noteworthy or something that you can decipher through the things. 20, it says if 3a plus 2 plus 3b plus 7 is equal to 25, what is the value of a over 3 plus 4 and, by the way, this is the sum or a sum, and b over 3 minus 9 equal to, okay, all right, okay. Now this is a crazy question, is it not? Yeah, it does look crazy to me. It does look crazy to me. But we got skills, don't we? We got skills. Part of me feels like we need to solve for A, right? Yeah. If we can solve for A and B, I think we stand a chance. But now this is going to be quite complex. You see? Going to be quite complex. Gonna be quite complex, gonna be quite complex, gonna be quite complex. Understand, Jay? But there's other things we can think about, you see. There are other things. It's either we start with this one or we start with that one, but this one looks a bit uncomfortable. It can't. This one looks a bit uncomfortable. Okay, let's just deal with it. So 3a plus 2 plus 3b plus 7 is equal to 25. Now, what I can see there, this is 200 plus 25. I can split this and then continue to split it so that it looks like this. So if I can say this is 3a plus 2 plus 3b plus 7, 2025 is nothing but 2000 plus 25. First time, J. Yeah, not 200, but 2000, 2000, 2000, 2000. Get loads hair, get loads hair, get loads hair. 25 uvela kanjani? 7 times, what number can I multiply by 3 and add 2 to get? Okay, the second one, 25, I want 7 to be involved. So what is it? It's 3 times 6, 18 plus 7. Yeah, that's the one. It looks like heat. It looks like heat. So 3a plus 2 plus 3b plus 7. Now let's leave this one. This one can be 3 times 6 plus 7. So you see, we try to write it like that. Get it? Yebo. And 3 is the coefficient. So this means we are trying to say b must be equal to Sigiza. So that one looks right. Because this is 18 plus 7, that's 25. Ne? Yeah. Eh? Wait. 18 plus 7, yeah. 2 goes there to 20, and then the 5 is 25. Okay, cool. Cool. Yeah, 8 plus 7 is 15. Things like that. Now let's try to deal with the 2000. What is it in terms of 3 times 1 plus 2? What is it? 2000. Yikes. Yo. In any case, we can say 2000 minus 2, that's 1098. But yeah, ndiyithandile, yeah. Izosharasa. Yintoni ngoku sesisondele kangaka? Hey, undenza ntoni na? Besisondele. I'm trying to think, how will we break the 2000? I am confused. Okay, let's just do some trial and error. If we say, for example, let's just say 6,600 times 3. Just want to see something. This is 0, 0, 18. Right? So this is 1,800. That's not quite close. I want something that gives me 1,998. That's what I need. Okay. Yikes. This is so close, though. This is so close. What about 700? Let's just say 700 times 3. So this is 0, 0, 21. Slightly above. Okay. Cool. We're close. So this thing must be between 600 and 700. So it has to be there. Okay. Yandichana kodwa. Ngathi ndisisokolisile nje, guys. The other one was easy. The other one is not. Kanti intoni ngawe wena, man? What are you doing? What are you doing? What are you doing? What are you doing to me? When are your last questions? This is on the Makfiwala. Okay. Let's just leave it like this now, guys. Let's just see. Sometimes let's start with this one. We know that this is a over 3 plus 4. Someone tells us that we're adding these things because it says the sum. Let's see what is this going to be. We sort this on 3 times 4, 12. So this is a plus 12 over 3. Knowing how to handle this. 3 times 9, that's 27. So this is b minus 27 over 3. Okay. So the common denominator is 3. Then we get a plus 12 plus b minus 27. So we've got a plus b minus, now 27 minus 12, kimang. This is 5. This is 1, that's 15. So it's about minus 15 all over 3. I see it. It's not helping. Damn it, man. It's not helping. Bengicinga uba kuzothini kanene. But I think that technique is good, but my problem is that izoba ngubani le. What is that supposed to give me? Okay, maske siqala apha izoba ngu-1998 plus 2, for example, for me to get that. Very close, guys, but that is 18. Ke tsebe ke tla e reng ntho wena. Ke tla e ira biyana. What I'm weak, ne? I guess swag die boy, man. How can I struggle to deal with these things? Because I split the thing and then I divide the number by 3, man. Long division. So 3, damn it. That's all I give me. It's a simple so I went, man. Now we know that 3 doesn't go to 1, so it goes to 19. It goes 6 times. 6 times 3, that's 18. Yeah, most. Minus 9 minus 8 is 1. Tero. We drop the 9. 3 to 19 goes 6 times again. 6 times this is 18. Minus 0, this is 1. We drop the 8. Yeah. Kini namadota. Sikubonile wena siqhela la way. Damn it, man. Intrela hampe waits. Now this implies that 3a plus 2 plus 3b plus 7 is equal to, so let's take you, sir, drop you further down a little bit. So now this, we know that this 1998 is nothing but 3 times 666, excuse me, this is 3 times 666 plus 2 plus 3 times 6 plus 7. Now we rotate. We rotate like it is. Yay, whatever. Dintho tse makatsang. Ho tjho hore he bana ba ntate. A wa rona ke 666. Ha ile B wa rona a ntse a le 6. Hobane ntho tse dingwe di a tshwana. Ha di tshwana fela. Re tlo re ho tjho hore A wa rona ke 666 and le B wa rona ke 6. Jwale he, ha re etse ntho tsa rona jwale. Re tlo re then A over 2 over 3 plus 4 plus B over 3 minus 9. Or ifama. Now this is going to be 666 over 3 plus 4 plus 6 over 3 minus 9. Now we know the things there. Could we divide this by 3? I know 6 divides 3, 6 divides 3, but will it divide 3 indeed? Khawuthi sijonge sithi ke ngoku u3 ku666 uthini indaba yakhona. 3 ku6 uyakayi-2, 2 times 3 6 0 hlisa 6 2 uyakayi-2, 2 times that 6 out. Bese sidropha lo wokugqibela uyakayi-2. 10 ngayibonanga lento. 2 2 2 Oh, ho. So sesiyayibona ke ngoku 2, 2, 2 plus 4. Right? Now, plus 6 divided by 3 is 2 minus 9. So this is now 2, 2, 6 minus 7. 2, 2, 6 minus 7 gubani. 16 minus 7 is 16 minus 7 gubani kane 9 ne? Yeah. So this is going to be 9. 1, 2. Sabuya nayo. Ayi wena masengiqhela. Okay guys, bekufiwa kancinci apha ne. Khona indawana nje efuna ukusingcwaba siphila. Kodwa ngoba kasingcwabeki singo-die hard. Hayi akekho na halo re patuwe fela ka ntho e sa buwing monna. E tlo pata dihole fela. E tla ntshwarela he haeba nthwena ha e kene hantle ditsebeng tsa lona. Nna ha ke le gwake nna. Nna ke a ipuella fela. Alright guys, to avoid making this too long, let's cut it here. If you want this memo, it's going to be in the description down below. That's just the thing. And yeah, it's going to be in the description, this thing. And yes, if you want a copy of this little thingies, it's going to also be in the thingies, in the description. Alright. I hope you've enjoyed the video, guys. Give it a thumbs up and watch. But remember, the best strategy is to pause the video for each question, attempt the question before you watch my solutions, and you will see how sometimes I twist and turn trying to get the right solution. It's not so easy sometimes. As you can see, a bit of thinking that is somehow masterful can take us home. But sometimes our thinking can fail us, and when it does, well, we just try again. That's just the way life is supposed to be lived. You live through experience, and the experience is going to tell us that we need to do our very best at all times. Okay, now folks, I'm going to do the next 20 questions in the next video. Please watch out for it. We're gonna go through these nice questions and of course share some insights into how they should be done properly. All right, have a good one and good luck with your exams. Bye-bye.